Howdy, Algebra 1. This lesson is about units of measurement and how we can use units of measurement to help us know what to do when solving math problems. So unit analysis is basically looking at how the units get affected when we do math in real life situations. Like for example, if you wanted to find the perimeter of this rectangle, you would have to add up all the lengths. So you got 3 feet here, 5 feet here, and you're going to add up all these feet, and you're going to get a bunch of feet. So when you add or subtract quantities, they have to have the same units of measure, right? So 5 feet minus 2 pounds doesn't really make sense. The sum or difference will have the same unit of measure. So basically, if you add up a bunch of feet, you're going to get a bunch of feet. Bada bing, bada boom. But when you multiply and divide, different things happen, right? If we wanted to find, say, the area of said rectangle, we would multiply length times width. 3 times 5 is 15, but feet times feet is feet squared, right? And so we call those square feet, and then that's the units of area. 15 square feet. When you multiply feet, you get feet squared, square feet. If you did feet divided by feet, the feet would cancel out and you would just have no units. But generally you don't end up with no units when you have units canceling out with division. It's usually because you are trying to change the units into something else. For example, if I wanted 30 feet per second, a lot of times speed of like projectiles like bullets or BBs are given in feet per second. Say I wanted to know, well, how fast is that in miles per hour? Well, what you could do is you could look at the units and say, well, I want my feet to cancel out, so I need to basically divide by feet, or in a sense, multiply by a fraction that has feet on the bottom, and I need to change it into miles. And my brain / internet tells me that there are 5,280 feet in 1 mile. So then my feet would cancel. So right now, if I did this, 30 times 1 divided by 5,280, that would give me miles per second, which should be a pretty small number, like a decimal, 0.00 something something, because you're not going to go very many miles in 1 second. But if I want to change those seconds into hours, I can multiply. Now here I got seconds on the bottom, so I want seconds on the top, so they'll cancel. And I want to end up with hours on the bottom. And the internet says that there is, in 1 hour, see there's 60 minutes, and each one of those is 60 seconds. 60 times 60 is 3,600 seconds in 1 hour. That would make my seconds cancel out, and I would be left with miles per hour. And now the units told me what operations to use. I go 30 times 1 times 3,600, and then I got to divide by 5,280, divide by 1. Multiplying and dividing by 1 really doesn't do anything, so it's just going to be 30. I'll do the multiplication first. I'll do times 3,600 and then divided by 5,280, and that's about 20 miles per hour. So, well, go back. Squiggly, approximately equal to 20 miles per hour. Cool beans. Okay, check out example 1. You work 8 hours and you earn $72. What is your hourly wage? Well, what would the units of my hourly wage be, right? Units for your hourly wage is usually dollars per hour, right? Dollars per hour. There's different ways to write dollars per hour, because per translates into divide. So dollars divided by hours. Just like on the last one I had, it's miles divided by hours. Same thing. So you could write it like this, dollars over hours, or dollars per hour. So, how does that help us? Well, to get our wage, we need to do dollars divided by hours. So, go back. $72 divided by 8 hours. You're in the way. Calculator. 72 divided by 8 is 9. So this is 9, and then what? It's dollars per hour. Dollars per hour. So that's one way to write it, but normally, like this is like the mathematical way to write it, but normally if you were just talking to a human, you would say $9 per hour, something like that. But that way, we use the units to tell us what to do with our numbers. Ooh, a sandbox is in the shape of a rectangular prism. That's a box. Its dimensions are 8 feet by 6 feet by 15 inches. Warning, 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 the units are different there. Feet, feet, inches. Gotta keep that in mind. The sandbox is 1/3 full of sand. Ding! And sand is being poured into the box at a rate of 2.5 cubic feet per minute. Ping! And now we want to know how long is it going to take to finish filling the box with sand. So basically, we need to know how much sand, or how much volume, how many cubic feet of sand is yet to be added to fill it up. And then figure out how many minutes it will take to fill that up, if it's filling up at this rate. So first we need to find the volume. So if we find the volume of the whole box, first we would need to change this into feet. So inches, and then I'm going to multiply by, and I didn't mention this last time, but you're multiplying by 1 basically. You're multiplying by a fraction that's equal to 1, right? And I want to have inches on the bottom so that my inches will cancel out, and feet on the top so that this 15 inches, that's the height of my box, will end up being given to me only in feet. So I know that there's 1 foot and 12 inches. There's 12 inches in 1 foot, right? So 1 foot and 12 inches are the same thing. So 1 foot over 12 inches is the same as multiplying by 1, because you got the same thing on top and bottom. Anywho, what happens is 15 times 1 divided by 12. So 15 over 12 is 1 3/12. 1, so that'd be, I'll show you what I'm thinking over here. 15 over 12. That's the same as 12 twelfths plus 3 twelfths, because 12 plus 3 is 15. 12 twelfths is 1. 3 twelfths is 1/4. So this is 1 1/4. Or I guess if you just had a calculator and did 15 divided by 12, you would get 1.25, which is 1 1/4. So 1.25 feet. All right. So the volume of the whole box is length times width times height. Length times width times height. And now we have them all in feet. So it's 8 feet times 6 feet times 1.25 feet. Okay, so 8 times 6 times 1.25 is 60. So that is 60 feet times feet times feet is feet to the 3rd power. So 60 cubic feet would be the volume of the entire box. But we already have it 1/3 full of sand, right? So we only need the remaining 2/3. So we want to find out really what's 2/3 of the volume of this whole box, because that's how much sand we really need to add. So 2/3 of the volume is 2/3 of 60 cubic feet which is 2 divided by 3 times 60. 40. So 2/3 of 60 is 40. That makes sense. So that's 40 cubic feet of sand. And it's loading at a rate of 2.5 cubic feet per minute. Okay, so what are we going to do? We've got, or rather we need 40 cubic feet of sand being put in at 2.5 cubic feet per minute, right? But I want to get an answer that is in just, what are we talking about? How long does it take to finish? So in just time, right? So the time I'm dealing with here is in minutes. So if I want to say, give me that in minutes, then I need to multiply by a fraction that's equivalent to 1, but I want my cubic feet on the bottom, and then my minutes on the top, so that I end up with minutes and my cubic feet cancel. Well, 2.5 cubic feet of sand go through in 1 minute. So 1 minute gives you 2.5 cubic feet of sand. So we end up having to do 40 times 1 divided by 2.5. So calculator, 40 times 1 doesn't do anything, so then we can just move on to divided by 2.5, and that is 16. So it takes 16 minutes to finish filling that up with sand, which means it took 8 minutes to get that first 1/3, and then it'll take 16 minutes to get the second 2/3 in there. So it would be a total of 24 minutes, but their question is, how long does it take to finish? 16 minutes to finish. Ding! All right, time to do some practice.